request is asking for the pH of a solution. After you add an amount, in this case I'll use 39.32 milliliters, and concentration of 0.114 molar, and this is all HCl, and it's added to 38 milliliters of 0.216 molar KOH. So this is my base, this is my acid. Now it's asking for the pH, and it did not say it was neutralized, so that means that these two will not be equal to each other most likely. Okay? So they're not equal to each other, so we have to find out how much we have on each side. So if we multiply these together, we'll get millimoles of the OH and millimoles of the H. 39.32 times 0.114, and this equals 4.48248 millimoles of the acid, and then 38 times 0.216 equals millimoles of the base, which is 8.208 millimoles. So as you can see, one of them will be bigger than the other. In this case, the OH is bigger than the H. So you subtract the H from both sides, because you initially have this many, you change it by this many. When the acid and the base neutralize each other, the 8.208 minus 4.48248, for example, would give us a 3.72552, and that's millimoles of OH that are left over. There is 0 millimoles of the H left over because it all gets neutralized. To find the pH, that's where we want to get to. To find pH, we know there's a couple different ways of finding pH. One is the negative log of the hydrogen ion. But in this case, there's 0 hydrogen ions, so the hydrogen ion isn't very helpful. Instead, we use the hydroxide. To get to POH, we use the negative log of the hydroxide concentration. And then to get from pH to POH, the equation is 14 equals pH plus POH. So if we have the OH, which we don't have here, this is just millimoles, we need the concentration of the OH. Concentration is moles per liter, so we put in our 3.72552 millimoles, and then we have to divide it by the total volume in liters. I'm sorry, in milliliters, make it easy. If you have millimoles over milliliters, you add the 38 to the 39.32, 39.32 plus 38, that gives us a total volume of 77.32 milliliters. 3.72552 divided by 77.32 gives us a molarity of 0.04818335. That's including everything on my calculator. And then we just take the negative log of that, and this gives us a POH value for this data of 1.317, 1049, and then we do 14 minus that, and that should give us a pH value of about 12.682895, and that's 1, 2, 3, 4, 5, 6. Quest should accept this answer, I think, to that digit there. So for this question, that would have been this answer based on the data. So you have to consider the neutralization that happens and the leftovers. So it's kind of like a little bit like the stoichiometry problems where we have excess, but you actually have to focus on the excess to find out how far it's past the neutralization point. Questions or clarifications on that? A little more sense?
Yeah.
good news is it took this problem that used to be on the actual test, and it took about it takes some time to do it. It's a challenging problem. It's a little it is a little more challenging, but if you understand the stoichiometry behind it and the pH behind it, this problem kind of incorporates everything we've done in the whole unit almost. I mean, it covers everything. It's not exactly an easy problem, but once you see it once, it's the same setup for all of them. You got an acid to base, and you know the amounts of both. Chances are you're trying to figure out either the molarity only or the pH. And you just got to watch out when you get to molarity, what's it the molarity of, to see if you have to go through extra steps. If this was acid, if this was, this number was over here, you had more acid, then you just take that and you're done. But you got multiple steps because of the pH-pOH relationship.